Waiting, inventory, overproduction, those are things that you're not going to be able to probably attack in a 8-hour period of time or a kaizen event that only takes 2 days. You should never ignore them. They're there, right? And they could be a bigger problem than what you're actually looking at. So it's something to look at maybe for the future. Why is the whole work cell waiting, right? What's the point of improving this particular work cell when there's no material here?
Thanks for being with us. I was super excited when you said yes, because we met previously in your past job, and you have an extensive experience in lean and in tier one, mainly tier one suppliers. For sure, you've done kaizen. Some of them was trying to reduce waste, including motion waste. We're talking about motion waste. You seem to have a large experience of trying to reduce or eliminate, if you can, motion waste. Do you see any different type of motion waste?
So when you're looking at a work cell and you're looking for waste, right? Toyota identifies 7 different ways, right? And there's a whole philosophy behind it. The 7 ways: you have inventory, you have transportation, but when you go to a work cell, the most common one that you see is usually motion waste.
Yeah.
You can see waiting also. You can see inventory, right? But like waiting, inventory, overproduction, those are things that you're not going to be able to probably attack in a 8-hour period of time or a kaizen event that only takes 2 days. You should never ignore them. They're there, right? And they could be a bigger problem than what you're actually looking at. So it's something to look at maybe for the future. Why is the whole work cell waiting, right? What's the point of improving this particular work cell when there's no material here, right?
Right.
That's a bigger problem, right? But you're not going to solve it today. So go look at that later and create a project behind it. So now we want to go to the work cell and do a kaizen event. What you're going to mostly see is motion waste, right? So the types of motion waste that you will see when you go to a work cell is the operator moving around unnecessarily. It's necessary for them to do the process, but the process could be designed better so they don't have to move around so much. So what we're looking for is reaching. Are they reaching too far? Are they walking? Are they moving back and forth too far? Are they rotating 360 degrees? And why are they doing those things? The part locations are key, right? The machine location, why are they reaching so far outside the machine? Can we move something closer? Usually there's a reason. It could be, this is where the power outlet was, so we're going to plug our thing in over here, our label maker or whatever, or this is where the airline is. So now we have to put the machine over here, but the conveyor is over here. So now I have to walk 6 feet, between the machine and the conveyor, because that's where the utilities were, right?
Right.
So when you're looking at the process, those are the easy things to identify is when the operator leaves that spot, what are they doing, right? And why?
When you were working for injection molding in the work cells, what was the most common waste you would see?
The waste that you see in an injection molding work cell is probably different than what you would see in an assembly work cell. In assembly work cell, you might have a lot of different manual operations, but in an injection molding work cell, the machine is going to make a part every cycle, no matter what the operator does, right? So the machine is going to keep going. It's going to say, here's a part every 60 seconds, and the operator has to keep up with the machine. So when you're looking for waste, the most common thing that I've seen is the packaging of the part, especially in automotive, is usually large bins. So the operator has to walk far to get to the bin, because that's where the forklift could deliver the bin. So they can't bring it right up close to the machine because it's kind of dangerous. We don't want to be too close to the operator. So they have to, and they're big bins. So they have to reach into the bin, right to the bottom. And then when the bin is full, then they don't have to reach as far, but they might have to reach across the bin, right? So we have these large bins. So this is a common thing. And also for an injection molding machine, the output is usually on one side, and that might not be convenient. So they we'll usually attach a conveyor to it. So the conveyor will bring the part closer to where the operator is. But those conveyors are sometimes the ones that they found in the corner of the plant when they created a new work cell. So they have a 6-foot conveyor instead of a 10-foot conveyor. So the operator's table is 4 feet away from where the operator is. So they have to walk, right? But the cycle of the machine is 60 seconds. And if the operator has the time, then nobody really worries about this extra motion waste that they have to do because they can keep up, right? But the problem with that is they could be doing some more valuable type of work. They could be doing better inspection, but they can't because they have to walk around so much. And at the end of the day, they're going to be very tired, right? So a lot of things solutions that can be put in place are smaller bins, right? So instead of one big large bin, you have a stack of little bins, and then you can add a flow rack or something to bring it a little bit closer. And they don't have to move large bins, so they can have it in that one spot where they can reach it. As well as for larger bins, you might have a tilter, so it tilts up so the operator can reach, properly into the bottom, or a rotating device like a turntable, so that when they're done on one side, they can rotate it to get to the other side. So it's basically what you want to do is try to present the packaging or the part to the operator as easily as possible, right? So they don't have to reach, they don't have to bend, they don't have to walk. And that's really the goal there for motion waste, especially in injection.
Okay, seems like the bin size is driven by the how to optimize the truck or the delivery to the.
Yeah, of course. 45 by 48 that fits two side by side in a 52-foot truck, right? Yeah.
Yeah, it makes sense at some point, but yeah, that's a good one. What are the other different tools you've been using to reduce waste over the years? If we're talking about mainly like a work cell, what do you like to implement to reduce the waste?
One great example for a tool that we use to improve motion waste in assembly was our process was an operator at a machine. So the operator had to load a part into a machine, and we're making exterior automotive components. They're about maybe 24 inches wide or whatever. So it's a part that the operator has to hold with 2 hands. So they're going to load the part in. They're going to press the button. Machine's going to do its job, which is install some clips or tape or whatever. And then the cycle is complete. They have to remove the part. So when they load the part, the machine cycles. It takes about 30 seconds. So they go to prepare the next part. So they're on, say, the right side of the machine. Then when they're done, the machine is done, they have to go unload the part and then go back and get the new part and put it in. Because it's a large part, they have to hold it with 2 hands. So what we wanted to do, when you do that, you have to turn 180 degrees. You have to go to the machine, you have to turn to the left, unload the part, then you have to turn to the right. You might have to take a few steps to grab the next part, put it in. So what we did was we implemented what we call auto eject on the machine. So when the machine is finished, it ejects the part so that the nest where you put the new part is empty, right? So now the operator is preparing the part. When the machine is finished, they can take that part immediately, go to the machine and load the machine. Then they're in the machine loading it, they can take the other part out, or it's already been ejected out, depending on how it is. So an older machine, and they can just go to the left. So you're going from right to left, they don't have to go over and back because it's just a simple flow. So on an older machine, it's going to be hard to spend money to create some automation. So that's not always possible. But when we presented this to our engineering group and said, look, when you design the next machine, give us something that'll eject the part. Right. They're like, no, it's too expensive. We don't want to send it down a conveyor and it could damage the part and all that stuff. So the solution was 2 pins on a cylinder. And all they do is they raise the part up like this. So we have a nest where the part is sitting. When it's done, it raises it up. So the nest is empty and the part is above the nest.
Okay.
So now they come in with the new part, the nest is empty, they put it on, and then they take the old part out, or the completed part, they take it out, and then they pack it, right? Press the button. So it's a little thing where you save a couple of seconds, but over the course of a day, a shift, a week, all that turning and those extra seconds, they all add up, and it's a big difference. So
okay,
one good example.
That was a good example, yeah. And what are the what are the impact for the employees? I mean, I would think that they would all be like, oh, that's good. Let's do that. Whatever can reduce me moving around or searching around. Like, I don't know anyone who really liked that.
Yeah. Nobody likes to move around in their job. So anything you can do to help the employee move less, they will be happy. But it's sometimes they just don't know. It's something that's been part of their job for so long that it is second nature, right? So we've always reached over here. We've always loaded the part and then not loaded and unloaded the part and waited for the machine. All these things are normal, right? So when you present a new improvement that reduces even a second or two of motion, they're like, oh yeah, it's not a big deal. But until they start doing it, and they do it for 8 hours, then they realize how much moving they've done before and the difference it has made. So they'll notice at the end of the week that they're less tired, you know, that their muscles are not as sore, or they're different muscles, you know. Eventually you will reduce the ergonomic impact on the operator. And it's something that operators really, employees, even you and I, when we do our jobs, we don't consciously understand how much we're moving, right? And until you change, you don't see the impact.
Yeah, exactly. And you mentioned searching for tools, searching for jigs, searching for information. I think this, especially what we do in assembly lines, I see a lot of searching for tools or parts. Talk to me about any experience you could have, like searching waste, and how were you able to tag that and find a solution?
One of the big impacts for motion waste can happen in a changeover activity. So when you have an injection molding machine or a CNC machine, I worked with a supplier with a company that was doing CNC machining. And every time you do a changeover, you have to change the tools that you're using for the next job, right? And the cabinet was full of different tools for all the different jobs. And they were labeled, but the label was worn off and it was hard to read, and someone had put old tools in there and they were in the wrong spot. So now it's time for the changeover. They look for the tool that they need, and it takes them a lot of time to search for the right tool. So this searching activity was taking up most of the changeover time instead of actually changing the tool, right? So the basic concept for a changeover is they prepare all the tools in advance before you even stop the machine, right? So that when you're ready for the changeover, you have everything you need. So what we did was create a tool cart, right? So it's not going to be possible to fix that crazy cabinet the next day, right? It's something that you could do in the next month or two. Buy a new cabinet, label everything. It's going to take some time, but you're going to do it and it's going to look beautiful. But in the meantime, let's create a little tool cart, okay? Now, before you stop the machine, you go search all those things that you normally spend searching and put them on this cart. So you have the right tool. You have, the different cutters that you need. You have them labeled properly. Now you're going to stop the machine. You have that cart right beside the machine where you're going to make the change. And then you just have the tools that you need, the wrench, the right socket size to do the right thing. And you've basically cut your tool time in half, your changeover time in half, without spending really any money except for like a little cart.
Right.
So a lot of it has to do with the preparation and having things in the right place ahead of time.
Right. And sustain it.
Well, of course. So after that, you're going to say, okay, well, how do we do this, right? How do we do this forever, right? So let's clean up our area. Let's make sure everything's in the right spot. Let's make sure the tools are maintained, that they're all sharp, that there's no old ones in there. And this tool cart, let's standardize the tool cart. So we have a place for the job list and the tools that are required for that list. And we know that if the tool changes at 2 o'clock, we're going to make the changeover. Then at 1 o'clock, we're going to start preparing for that changeover. And it's not going to take me an hour to find those tools because I've already cleaned up that whole cabinet. So it's going to take me about 10 minutes. But I'm still going to do it, and I'm going to have it ready here on this cart.
You've worked with like sub-assembly or assembly lines a little, and what were the different waste you would see there, and guess a lot of motion waste too, but
Yeah.
do you have any example or?
Yeah, in an assembly process, assembly lines, a lot of times the impact of the operator is bigger, right? Because the operator has to do some task. It could be outside the machine, it could be dependent on the machine, and the machine could be waiting for the operator to, install some clips before it could cycle, or whatever they need to do. And when I think of assembly, it's the operator loading the machine and then pressing the button, and the machine cycles. But there's other types of assembly. It could be robotic, it could be an assembly line like a Bosch line or something, a line that's connected together. But usually it's dependent on the operator performing a task using a screwdriver or whatever. So a lot of the impact there has to do with how fast they can do their job, or how easy they can do their job.
Yeah.
And one of the things that we always struggled with in the plastics industry was the part not really fitting very well in the machine, right?
Really?
Because
Okay.
plastics, it can grow a little bit. If it's a little bit colder, it can shrink a little bit, and it's not perfect. But when it's installed, it fits because it has some malleability. It can move around a little bit. It can fit properly when it's installed perfectly. But when it's loose by itself, it doesn't sit, perfectly
Yeah.
in a nest, right? So now it's not sitting perfectly. The sensor doesn't work because it's a little bit off by a couple millimeters. So they're trying to start the machine, but the sensor isn't engaged, right? So little things like that have always been a bit of a struggle, I know, for me anyways, in the plastics industry. So that's where you need to figure out these are the types of things that an operator will struggle with and not really tell you every day, because for them it's part of the process. They're always dealing with it. They're like, oh yeah, it always happens. I got to spend an extra 3 seconds trying to manipulate it so it kind of fits properly. But a simple solution is just having a tighter nest, right? Having some pressure points that can hold it down better, so the operator doesn't have to wiggle it around too much, right? So those little things an operator struggles with every day, it's just part of their process. They don't even think about it anymore.
Yeah.
Those are the things that really are that motion waste that you can address very quickly when you do a kaizen activity.
How can you be able to make them realize that this is not normal? This should not be normal, and next time you should just raise the flag.
Yeah, so the question is, how do you get that change culture ingrained? So you can train an operator to identify that. They can say, yeah, we did this Kaizen event, I don't have to struggle with this anymore. But one of the problems is you also have to train the management and the maintenance people to understand the same thing.
Yeah.
Because an operator that's fully trained now, they'll be like, I shouldn't have to struggle with this. So now the Kaizen event's over, they're going to go to a different job, they're going to have the same reason, they're going to go to their manager and they're going to say, I'm struggling with this, and the manager's going to say, yeah, okay, no problem, we'll look at it, right? But it's probably not going to get fixed unless the manager and the maintenance staff and everybody is on board, right? So in order to sustain that, everyone has to be involved, on board, and ready to react and fix the problem.
I saw that you have a page about lean simulation game.
Yes.
Do you still maintain it? Do you still update the page? I think there's 50 different games there.
Yes.
Would you use, how do you use it?
So during a Kaizen event, there's usually 2 goals. There's the improvement, but also the training of the operator.
Yeah.
So you're going to spend some time in the classroom. You're going to talk about lean concepts, the 7 ways or 5S or whatever, and then you're going to go out on the shop floor. And sometimes it's easier to teach those concepts with a little simple game to keep everybody engaged. So there's a couple games that I like to use. There's a lot of very complicated games you can get. You can buy a game for $500 or whatever, and it has all kinds of different components and Lego components, all these different things. But really, you don't need that. You just need a little simple game. And if I'm teaching about 5S, there's this game, it's called the 5S game, and it's all on paper. It has a jumble of numbers. There's 100 numbers, and they're all in a mess. And you say, can you cross out the numbers from 1 to 49 in order? So they have to search on the page and then find all those little numbers, and it takes a while. So then you give them the next page, and all the numbers that are not required are removed. So now it's easier to find the numbers. So it's like the sword
That's
set in
good.
order. The next step
Excellent.
is all the numbers are in a row. So how easy is it now? So then you do a little time study and you say, oh, well, it took you 3 minutes. Now it took you a minute and a half. And now it only took you 10 seconds, right? So what's important about these little games is that everyone loves it. They get it, it's a simple little thing, but you need to relate it. You need to relate it to the actual process. You say, okay, so we've played with these little paper games and these numbers. What does that look like in your area on the shop floor? How long do you spend searching for parts? What do you have in your area that doesn't belong, that is just creating clutter and creating more, just more noise that you have to look through, things that you don't need, right? And yeah, so it's important that you have something to engage, but ultimately you have to figure out how to make that relevant to your specific process that you're looking at.
Very good.
Yeah, one thing that's important when you're looking at waste is we always use time studies, and this is a concept that's been around since the early 1900s. Doing a time study on the process, and one of the reasons we do that is to identify what's the difference between the same cycle when it's going fast and when it's going slow. So when you do a time study, you're going to say, well, this time it took 30 seconds, but the next time it took 60 seconds. What's the difference, right? Well, so you can see that in the numbers, but you don't know the reason. So you still have to watch, while you're doing the time study, to understand, okay, we know we can do it in 30 seconds, but we're not, because on average, we're doing it in, 45 seconds. And sometimes it's going up to 70 seconds, right? And this could be a machine, it could be an operator. So the trick is, when you're looking at waste, what you're going to find is the difference between the fast cycles and the longer cycles. And then the question is, what's happening in those longer cycles? Is the person walking away? Is the machine faulting? Is there some error that's happening? And how do we solve that, right? And that gets you closer to the root cause, where you can identify the problem, fix the problem, and get closer to the average, best repeatable cycle.
And then start a kaizen and try to fix or find some solution.
Yeah.
You know the cause.
Yeah, one thing we look at is what's the fluctuation, right? So you can have a process that's running 30 seconds consistently, and it may be harder to find opportunities. But if you have a process with a lot of fluctuation between the different cycles, so sometimes it's 30 seconds and sometimes it's 60 seconds, then you know that there's potential there. There's an opportunity there.
Very good. Hey, thanks again, Martin, for doing that. Very appreciated.